Okay, let's see this question. So given one equation with two variables, with variable y and with variable x. So also we're given x to be an integer. So I would add y to be integer as well, because otherwise it's even more difficult to solve. So how do we solve this? So if we can make the equation in the factored form, somehow we can make the right-hand side a prime number, right? A prime number means it only has two factors, and the one multiplied by itself. So if we could do that, that would be one way to solve such equation. But then in between, we have to get rid of one variables to solve for the other. So let's see. So first, let's square both sides. So when we square both sides, we get rid of the square root sign. So we get y squared equal to x squared plus 15x plus 32. Now we want to use the property of real numbers. We want to solve x, y in integers with real numbers. So for real numbers, anything square has to be at least 0. Right, so we want to use this property in real numbers. So let's make perfect squares. So y squared is already perfect square, but we won't be able to make this side to be a perfect square. I mean, we're able to, but we'll get into fractions. So if, right, so we don't want to get into fractions. So what do we do? Let's do this. Let's multiply by 4 on both sides. So we also multiply by 4 on this side, because in this way, we can make 4y squared as parentheses 2y squared. So we can make a perfect square instead of working with fractions. Then the right-hand side will have 4x squared plus 30x plus 2 times 4, 8, 3 times 4, 12, 128. Let's see if this way is easier. Right, so 4x squared, let's try to make this to work with these two to make a perfect square. So 30 divided by 2, 15. So we want to make 2x plus 15 squared. Right, in this case, when we do the middle term, we get 2 times 15. Oh, hold on. Yeah, 2 times 15, that's 30. Then multiply by 2, that should be 60. Oh, I did it wrong. 4 times 15 did give us 60, not 30. I wrote it wrong. Yeah, this should be 60 because 15 times 4, that's 60. Yeah, so out of those two terms, we have made a perfect square, 2x squared, which is 2x parentheses square, which is 4x squared. The middle term will be 2 times 2 times 2x times 2 times 15, which is 60x. Then 15 squared. 15 squared, remember, is 225, right? But I only have 128. So minus 128. 797. So we have to minus 97. Right? Because here we added 225, but we only have 128. So we have to offset negative 97. So now we have 2y squared. Oh, what's the beauty about 97? 97 is a prime. We're getting closer to our goal. Now let's move Let's move negative 97 to the other side, become positive. Move 2y squared to be the same side as this. So we can write as 2x plus 15 squared minus 2y squared equals to positive 97. Right? We still have 2x plus 15 squared minus 97 equals to 2y squared. We're just writing in different order now on different sides. Why we want to do this? Because the difference of two squares on the left-hand side, we can factor into factors. So 2x plus 15 plus 2y times 2x plus 15 minus 2y. Then equals to 1 times 97, because 97 is a prime. Only one way to write into a product is 1 times 97. Now x, y, positive integers. So that's why I added y to be positive integers. Otherwise it's very easy to get into trouble. So now, because y is positive integers, so this, and also x positive integers, so this one has to be greater than this one. Because this one is add to y, this one is minus to y. Right? If we don't have y to be positive integers, so we can split into two cases. But for me, I want to do it easier. So let's limit y to be positive integer as well. So now this one, so this, let's write this. 2x plus 15 plus 2y has to be bigger than 2x plus 15 minus y. So that means that this one has to be 97 and this one is 1. This one is 1. Which means if we add those two, we can add those two now. If we add 2x plus, so let's write 2 steps, plus 2y. This has to be 97. And 2x plus 15 minus 2y has to be 1. So we have this system of equations to solve. So we can add those two equations. Because when we add, we get rid of y. Right? Let's add the two equations. 2x plus 2x, 4x. 15 plus 15, 30. Positive 2y plus negative 2y becomes 0. 97 plus 1, 98. We'll subtract 30 on both sides. 90 minus 30, 60. So we get 68. So 4x equals to 68. Then x equals to 68 divided by 4. So we get a 1, then 28, 17. So x equals to 17. Then it's easy to get, to substitute into one of the equations. X is 17, let's use this equation. 2x, so 2 times 17, 34. 34 plus 15 equals to 2y plus 1. Right, 34 plus 15, that's 49. 49 minus 1 equals 2y. So 48 equals 2y. So y equals to 24. That's it. The solution for this one is x equals to 17.